Technologies have been used by more and more education systems worldwide. Several studies claim that technologies can help to develop an effective learning environment. As an emerging technology, gesture-based devices have opened new opportunities for learning. Teachers can observe students as they perform specific motion to solve learning tasks and obtain feedback directly from the plain screen. This entire process improves children's gross motor skills. As it is important for children to learn from playing, it has found that games, especially those for children, play an important role in critical skill development. Recently, human-computer interaction paradigms, games, and somatosensory devices have been combined to develop a set of applications generically called gesture interactive game-based learning, which aims at the improvement of learning performance through interactive games. Gesture interactive game-based learning opens wide new opportunity to learn difficult contents by using new paradigms. For example, through body or hand movements, which provide a foundation for new learning models. These techniques are especially of interest in primary and secondary education for several reasons. Firstly, more natural interfaces can be made. Secondly, learners can use their body as a tool. This will reduce physical passivity and increases their motivation. Thirdly, the child can be supervised by the teacher while they solve specific tasks, and feedback can be obtained from the system in real time. Many studies reported that gesture interactive game-based learning can increase both the ability to learn and critical skills in different range of ages. However, the overall education of the children should stimulate other kind of ability rather than simply learning and critical competence. The motivation behind this project. The problem with most of the existing learning platform is that they are not so interactive. That makes it more difficult for children to learn the major concept as there is less sense of motivation and satisfaction. One of the major problems of already existing methods are the use of additional sensors like Microsoft Kinect, as with STM Pro, etc. Introducing interactivity and multimodality can greatly increase curiosity in children to learn. Objective. Our main objective is to develop an efficient web-based platform that help in learning with the help of hand gesture for children, and to combine gesture-based computing technology and a game-based learning model into one and the same. Our other objective is to integrate speech functions so that students can easily understand and to make this platform easy to use. Features. It is a web-based platform and can work in every devices. There is no need of extra hardware, and we integrated audio for easier understanding. The user interface is attractive and user-friendly. We also adopted method for easier navigation. The main feature is that this platform makes it easy to learn numbers and their word representation. Modules. We implemented 4 modules, namely handtrack.js for finding the position of the hand, handpose model from the TensorFlow.js, 3JS to design graphics, audio for easy understanding. Handtrack.js. It is a library for prototyping real-time hand detection directly in the browser. It frames hand tracking as an object detection problem and uses a trained convolutional neural network to predict the location of the hand in an image. The convolutional neural network is trained using the TensorFlow Object Detection API. It takes in a HTML image element such as images, videos, canvas element, and return an array of bounding boxes, class names, and confidence code. Handpose model. The TensorFlow.js handpose model detects hand landmark and uses a finger pose classifier to classify them. Inside a webcam source picture, it can recognize hand movements. Gesture detection works in 3 steps. First, it detects the hand landmark inside the video picture, then estimate the direction and curl of each finger, then compare the result to a set of gesture description. Here the first step is performed by the TensorFlow's handpose model. Then the step 2 and 3 are handled by the fingerpose library. 3JS. It is a JavaScript library, an application program interface that uses WebGL to produce and display dynamic 3D computer graphics in a web browser. When we give a renderer a scene and a camera, It draws the piece of the 3D scene that is inside the camera's frustum as a 2D image to a canvas. Audio is the fourth module. Here, a speech synthesized utterance interface of the web speech API is used for the audio integration. A speech request is represented by the web speech API's speech synthesized utterance interface. It includes the content that the speech service should read as well as instruction on how to read it. Example, the language, the pitch and the volume.
This is the working of N-alpha, a gesture-based interactive game. The name itself symbolizes both number and alphabet. The idea behind this game is to provide the knowledge through a creative way. Through this game, anyone can understand and study both number as well as number name. Here are 3 levels and each level consists of 2 stages. While clicking, we reach level 1, and in level 1, right in right corner, 41 is written, and speaking button, which while clicking it, we can hear a voice, and after allowing camera, we reach into the selection phase. Now we can proceed with the selection, and we reach movement phase, and after allowing, we just move into the movement phase by swapping between 4 and 1. Now clicking the arrow, we can move to the next stage in level 2, and it is we have to find 27 from 72, so we have to just swap between 7 and 2, and in left top corner you can see your score and level. Now we reach the end of the level 1 with score written, and we are now moving to the level 2 stage 1, and after here there are 3 numbers, and we have to swap between them in order to get the number, which is 301 here, and we are continuing swapping between 3 and 1. Now we are going to swap between 1 and 0, and at last we found it. Now we are moving to the next stage by clicking the arrow, and now we reach the stage, and here it is 956 as given, and we have to find 965, so one swapping is needed. Just like that we just did it. Now we are moving to the level 3. The score is written here, and we have reached in the level 3. In level 3 we have to face 4-digit numbers, and here we have to swap, minimum of 2 swap is needed, so we just took 1 and swapped between 4, and now 0 and 3. Now we reach the end of the level 3 stage 1, and we have to move to the next level, and here everyone has to face a lot of trouble, and here it is one of the extreme cases in this whole game. This moving 9 from this end to that end, one of the rare cases that exists, so we have to do it. We have to select 9 at first, and through gesture, and after selecting it we have to swap between 8, and we done it. Next we have to select 9 again and move it to the next one, that is 5, and we swap between it, and now we have to move between 9 and 6, and after selection we can just move it, and after every stage you can hear a voice saying that this is successful section. And now we have to look into our scores, that is 60 after 60, and thus the game is completed.
It is important to develop understanding skills in children, and this start from learning numbers and their word representation. The more interactive the classes become, the more interested they become to learn. Even students with disabilities can study number and its word representation, easily reducing their gap between the normal students. It improves analyzing ability of a child in order to get more easiest way to solve the given problem. Scoring creates competitive mind, which makes everyone to give maximum output, thus increasing speed of learning. Conclusion. The game-based learning, a recently emerged and highly exciting medium, actively engages students in learning through interactive environment. Studies have shown that game-based learning techniques help students learning difficult concepts. This is more evident in case of small children. Incorporating visual media is shown to help in understanding difficult concepts. Introducing interactivity and multimodality can greatly increase curiosity in children. Studies have shown that gestures influences the way we think, learn, and perceive the world. Gesture-based computing has received great attention and relevance in educational field. Now, many studies have attempted to integrate gesture technologies, major features like gestures and body motion of participants into learning activities ranging from physically related domain to cognitive domains. In this work, We combine gesture-based computing technology and a game-based learning model into one to make it more interactive for the children to increase their motivation and satisfaction.